Hi, I'm Jenna Brune, and I will be discussing the Tesmere and Wiedemann model, also known as the layers of necessity model of instructional design. This instructional design model was created by Martin Tesmere and John F. Wiedemann in 1990. It is a multi-layered framework designed to offer an alternative means of achieving quality instruction using a more flexible approach. In terms of context for use, this model was designed for the educational setting, specifically fitting within the K-12 realm, but it can easily be adapted to the graduate level setting as well. This model is also very flexible in nature, which I will be discussing more about later, but as an element of performance improvement, it could easily be integrated into the business community or other professions as needed. The reason Tesmer and Wiedemann developed this model is because they felt that there was a need for a more flexible, realistic approach for instructional design models than what was currently available. They felt that the current models did not adequately account for time and resource constraints, therefore not designed for long-term success. Additionally, they felt a new framework needed to be created that allowed for a more malleable approach, not requiring completion of each element to reach the end goal. A little bit more about the developers. Martin Tesmere, he previously worked as a research professor of instructional technology at the University of Colorado. He retired in 2010 and began working with the Navy on developing and designing training programs for fighter pilots. Overall, he enjoyed a 35-year career as a design and train expert for the military and various universities. John F. Wiedemann, he graduated from the University of Oklahoma with a degree in the field of curriculum and teaching. He previously worked as an associate professor of educational technology at the University of Missouri, and he published several journal articles and co-authored various books relating to performance improvement. As I mentioned previously, this model is a multi-layered approach designed to be flexible in nature and allow the developer to uniquely tailor integration to the necessities of their specific project. The overall design includes 4 process layers. The first 3 are identified, and the fourth is labeled as the nth layer, signifying the unlimited potential of this process. When something is labeled to the nth degree, it represents the unknown, meaning that this layer of the model can actually be expanded as much as needed for the given project. The first layer of this model is the initial phase, and the following layers gain complexity as the developer dives deeper into the process, with time and resources permitting. Additionally, this model allows for the developer to move through the framework regardless of completion of a given layer. It is designed as an open, flexible approach, adapting whichever layer the developer sees as the most applicable to their situation. This is a quote from Tesmere and Wiedemann themselves, which explains a little bit more about their process. The layers of necessity model is a series of instructional design models, one nested within the other. Different layers exist because project necessities vary. Each layer differs in the design and development sophistication contained within it. For situations with severe time and resource limitations, only the simplest layer of design can be used. For more time and resource-rich projects, a more complex or sophisticated layer can be used. So in other words, in this model, each layer is part of the other. They are all compounded, and depending on the specific goals for the project, one layer may be more appropriate than the other. Layer 1 is the typical starting point for most projects. It is the most necessary layer, and although it is not required because this model allows for the developer to begin at any layer. In this way, Layer 1 is viewed as the simplest layer and can be used independently without requiring progression to further layers. In Layer 1, there are 5 basic elements. First, situational assessments. You have to assess the current situation and identify the performance improvement needs. The second is goal analysis. Develop a conceptualization of the performance task. Then we have instructional strategy and development. Identify the strategies that are appropriate for the project. Materials development. Identify what materials are needed for implementation. And finally, evaluation and research. This is reassessment and revision stage of the plan before the official implementation. This is an example of how Layer 1 can be expanded for a specific project into multiple subsets. As you can see, each of the 5 components of Layer 1 can be broadened as the complexity of the project increases. This model allows for personalization, incorporating the developer's expertise and knowledge of what is most appropriate for the given project. There are many advantages to this model. It is a very flexible design and allows for the developer to move in the directions they see fit. It is also rather realistic in nature and designed as an all-encompassing model. Additionally, this model offers an open concept, meaning you can start with any layer. You do not necessarily have to go in order. Layers also do not require completion to move on to the next, which was a drawback Tesmere and Weidman felt other models at the time required. Therefore, they aimed at designing a model that was malleable and allowed for unique adaptation of whichever layer is the best fit for the given situation. Another advantage is that this model can be applied to nearly any organizational project, any discipline, including education, medicine, business, whatever you can see fit, it is applicable for a wide range of projects. There are also 5 categories of advantages addressed in the several journal articles I explored. First is task enhancement. The goal with this model is to enhance the work that is already created and not try to recreate something or reinvent the wheel. It is also principle-based. Principles, not procedures, govern design. Instead of requiring a more sequential flow of doing step 1, then moving on to step 2, and so forth, this model is nonlinear and revolves around a set of guidelines for each layer instead of a specific set of steps that must be completed. This approach aids in the flexibility and open concept of the model. Merge strategies. Layers are not separated by type of task, but the common purpose the tasks aim to achieve. Opportunistic perspective. You can modify, adjust, and improvise in real time. If a part of the plan is not working, it can be removed. If something needs to be revised or adjusted, it is also encouraged. The idea is that the layers are a revolving door, ever changing to fit the immediate constraints and goals of the project. Efficiency-based. Time and resource sensitive. You can design something that is good enough for now, meaning that it is as good as it can get or the best that it could do within the project limitations, and then revisit it later when additional time and resources are available. In this way, this model allows for a realistic adaptation to situations with the notion that it can be revised and enhanced later when additional resources are available. There are some disadvantages of this model. It does not provide a clear guideline for moving past layer 1. The examples of future layers are not well explained. They tend to be rather general and vague. Layer 1 is typically the only layer that is explained in depth. Because the model itself is so flexible and can be used in a variety of ways, it is understandable that the comprehensive example of future layers is hard to come by, as it is unique to the given project. However, that is still a limitation, as there is not a guideline to follow for the more complex components of this design. While the flexible design can be an advantage, it can also be a disadvantage because of the lack of structure. It seems that a healthy balance of both is needed to be more effective. In order for this instructional design model to have more success and widespread use, many in the field believe there needs to be a more well-developed set of principles and guidelines created for developers to follow. Specific design problems for the layers of necessity model. In the educational environment, it can be applied in many ways, specifically lesson plans and assessments, or even more widespread use such as unit plans. It could also be used for professional development or staff training, or if there are any building or district-wide initiatives or implementations, such as going one-to-one and using Chromebooks, or a learning management system implementation, anything from small scale to wide scale. This ID model could also be applied to nearly any profession for specific projects and initiatives in the given environment. It could be applied in the business world, the auto industry, the medical field. The possibilities are nearly endless with this model as it is so flexible and generic in nature. And this is my list of references.